This planet breaks every rule of how planets are born. Everything astronomers knew about planet formation just got flipped upside down. Meet GJ523b, a world so massive and dense that standard astrophysics says it shouldn't even exist. Located 87 light-years away, this planet was caught transiting its host star by NASA's TESS. At 2.55 Earth radii, it looked like a run-of-the-mill sub-Neptune. But when the NEID spectrograph measured its gravitational tug on its star, the numbers were staggering. GJ523b packs an immense 23.5 Earth masses into that compact volume. That gives it a bulk density of 7.8 grams per cubic centimeter, making it roughly 40% denser than Earth. Here is why astronomers are calling this a major curveball. GJ523b is just 169 million years old, practically a newborn cosmic infant. Standard core accretion models dictate that once a planetary core crosses 10 to 15 Earth masses, it should trigger runaway gas capture, forming a Jupiter-like gas giant with a massive hydrogen-helium envelope. Yet GJ523b is nearly 77% solid rock and metal, wrapped in exotic high-pressure ice and water, with barely any primordial gas left. What happened to its atmosphere? The orbit holds a massive clue. GJ523b is misaligned from its star's equator by at least 71 degrees, plunging over the star's poles. This orbital chaos points to a violent past. It may be the scar of a catastrophic collision between two planetary embryos that blasted away the gas envelope, or extreme planetesimal bombardment that superheated the infant core before gas could condense. GJ523b is now officially anchoring a newly proposed category of alien worlds, the mega-Earths. Could planets this dense harbor conditions we've never even imagined? Drop your theories in the comments below. Smash that like button, subscribe, and follow Deep Space Dive, and stay curious.